Welcome to another chemistry class based on organic chemistry made easy. And today we are going to talk about a very important aspect as far as organic chemistry is concerned. That is what shapes, right? You have heard about shapes in organic chemistry, where you heard something like the s orbital is what spherical, the p orbital is what a dumbbell or shape. But right now, we are not just going to talk about the s orbital separate. We are not going to talk about the p orbital separate. We are going to talk about how when we mix these two orbitals together, right? We are going to mix the word s orbital and the word p word orbital word together. You understand? The s and the word p word orbital word together. And the concept of mixing them together is what will lead us to what is known as hybridization. Right? Hybridization is very, very important as far as what organic chemistry is what concern hybridization. Now, hybridization from the name hybrid, right? You have heard about hybrid pawpaw, right? Hybrid what orange, where you mix a particular species of what orange with another species of what orange, right? Giving you what a new what species, right? So that is what is known as what hybridization. Right, so hybridization in organic chemistry simply means the mixing or what blending of atomic orbital to form a new set of what orbital. So we say hybridization, this is what simply the mixing or blending of atomic orbital the mixing or the blending of atomic orbitals to give you what a new set of what orbital, or to form a new set of what orbital, to form a new set of what orbital known as the what hybrid what orbital. Known as the word hybrid what orbital. Simply the word mixing or the blending of atomic orbitals to form what a new set of orbitals known as what the hybrid what orbitals. So we are going to talk about the various what hybridization, right? Remember I said we have the s orbital, we have the what p what orbitals, right? We have the s orbital. Remember we have the sp, we have the d, and we have the word f. But as far as it comes to this particular aspect, our major focus is on the word s and the word p word orbital. Note, our major focus is on the word s and p word orbital. Now we have just talked about orbitals, right? I've just talked about what orbital. What is an orbital? That's the next question. What is what and what orbital? An orbital. What is an orbital, right? You have seen something like this before in chemistry, right? So the question is, what is what an orbital? What is this, right? An orbital is a region of what space is a region of what space where there is what an orbital is what the region of space where there is a 98%. I will say something though. Just take note. Where there's a 98% probability of finding an electron. An orbital is a region of space where there's a 98% probability of finding an electron. Now, in some textbook or some lecturers might come to the board and tell you that an orbital is a region of what space where there is a 95%. Take note, where there's a 95% or more than what a 95% probability of finding what an electron. Note, your lecturer is also what correct. Remember what I said? I said 98%. And your lecturer is not saying 95 or more than 95. Note, 98 is more than what? 95, right? But it must not be less than what? 95. So it must not be what? 94. It must not be what? 90. It must not be what? 81. It must be what? 95% or more than what? A 95% probability of finding what? An electron. That is what is known as what? An orbital. We have seen something like this, right? Where the innermost, right, must contain how many electrons? 2 electrons. And the outermost must contain how many electrons? 8 what? Electrons. But you get to see that these electrons are what? Singly filled before pairing what? Occurs. So this is my first assignment. These are rules, right? Now find out the rules that states that the innermost shell must be what? The innermost shell must contain a maximum of what? 2. right? And the outermost must contain what 8. And also find out the principle or the rule that says that electrons must be what singly filled before pairing what occurs. That is your assignment. Make sure you submit my assignment. So that is just it. So let's move on to the next one, which is this what this formation or the major concept of what this hybridization, right? So let's move on. Let's move on. So we are going to first of all start with the word sp3 word hybridization, right? The sp3 word hybridization. The sp3 word hybridization. So this is just it. But note, in a normal carbon atom, in a normal word carbon word atom, there are 2 electrons in the s orbital and there are 2 electrons in the p word orbital. That means we are going to have something like this: h2 and word p word 2, right? In a normal carbon atom, we have what 2 electrons in the word s orbital and 2 electrons in the p orbital. But you get to find out that right now we are having what sp word 3. That means s is down 1 and p is what 3. So what led to the formation of this sp3 word hybridization? That is what we are going to discuss right now. Now the sp3 hybridization is formed when during excitation, one electron from the word s orbital jump during excitation. One electron from the word s orbital jump to the word p word orbital, making the s orbital have how many electrons? 1, right? And the p orbital having how many electrons? 3 what electrons. That is the formation of the word sp3 word hybridization. Let me just give you an example, right? You and your brother, right? Your mom got what? An orange. Gave your brother what? 2. And you now took 1 orange from your own and give to your brother. How many oranges is your brother having? 3. How many oranges are you having? 1. That is what is simply known as what? sp3 what? Hybridization. And this takes place during what? Excitation. This takes place during what? Excitation. So you must also be able to calculate the percentage of what? The X character and the percentage of the what? P word character in what the sp3 word hybridization. So when you say percentage character, let's say you want to calculate the percentage of what S character, right? S character in what sp3, right? In sp3 word hybridization. So you simply say what solution. You say what s1 what p3, right? So you simply say 1 plus 3 is what 4. So you say 1 over 4. Sorry, 1 over what 4. Because you're looking for the word percentage of what s. Say 1 over what 4 times what 100, since it's what percentage. So whatever it gives to you there is a what percentage what character of what s. You can see this do the same for p, where you say what 3 over what 4 times what 100. Whatever it gives to you there is for what p. So that is just what how we what it is. So let's move on without wasting much time, because these stuffs are what simply very what easy. They are very what easy. It's just for you to what understand the concept, just like the way I am doing it here, right? So you also have the word sp2, right? The sp2, same things happen, right? We already said the normal carbon atom what has what 2 electrons in the s and 2 electrons in the word p, and now we are having what sp what 2, right? So let's say we have s2, we have what p2. Now during excitation, this is what happened. During what excitation, right? Now the sp2 hybridization occurs in alkenes. Take note, it occurs in alkenes, benzene, phenol and cycloalkenes. It occurs in the alkenes, benzene, phenol and what cyclo what alkenes. So the sp2 hybrid orbital is formed when the 1 electron in the 2s orbital mix or blend with electrons in the 2p what orbital, thereby leaving 1 electron unreactive. Thereby leaving 1 electron what on what reactive. Now the 1 electron here in the s orbital will jump to the what p what orbital. Now instead of increasing the p orbital to what sp what 3, what is going to happen is that 1 electron that jumps becomes what on what reactive. And when it becomes unreactive, it is not needed in the what equation, right? So when it is not needed in the equation, we still are going to have our s1 and what p what 2. That is just how it is, and that is how we get our what sp2 what hybridization. So let's move on to the next one, which is what the sp3 what the sp what hybridization. The sp what hybridization. The sp hybridization is found in what alkynes and cyclo what alkynes. Is found in what alkynes and cyclo what alkynes. So it is formed by the mixing or the blending of the what one electron in the 2s orbital and one electron in the 2p what orbital, thereby leaving two electrons unreactive to form a new set of what orbital, just like what I have said. So you know they have s2p2, right? So each of them, one of them here is going to be what on what reactive, and when they becomes unreactive, you are simply going to have what s1 what p1. So you see, instead of writing s1 p1, we simply say what sp what hybridization, because each of their one electron is now what unreactive. So we say 2 minus 1, 2 minus 1, we are left with what 1, and we are left with what 1, right? So that is how we have our what sp what hybridization. So that is just how what it is when it comes to what hybridization, which is the mixing or the blending of atomic orbitals to form a new set of orbital, which is known as a what hybrid what orbital. That is what is known as what hybridization. That is what is known as what hybridization. If you need, if you need any clarification, any further clarification, drop it in the comment section so that we will know how to handle it. Maybe in our next video, if you need clarification, when I get to see your questions and stuff like that, I will get to make a video clarifying what you actually what need. So let's move on to another important aspect which I've been talking about, which is what the bonding in what organic what chemistry, bonding in organic what compounds. I remember when I started this class in our first class, when I was talking about the introduction to what organic chemistry, I said organic chemistry is a branch of science that is based on what carbon and its what compound, carbon and its what constituents and its what derivatives. So I say the basic or the major purpose of organic chemistry is based on what? I say it is based on what carbon, right? The major study of organic chemistry is based on what carbon, right? So what kind of bonding does carbon what undergo? This aspect is very what interesting. This aspect is very interesting. I remember I already talked about what bonding, right? I say bonding, the major reason of bonding is to undergo what stability. I want to be balanced, you want to be what balanced. So let's come together in order to attain what this balance. So the ability of me coming and you coming to attain this balance is what is known as what bonding. So that is just how we what it is. So which type of bonding does carbon undergo? That is the what question. Which type of bonding does carbon what undergo? And that is what we want to find out here. Remember, there was a time I did something like this, right? This is to tell you that carbon undergo what a type of bonding that is what is sharing what type of what bonding, sharing type of what bonding. But before I move on to talk about the sharing type of bonding in organic chemistry, I want to give you a breakdown of what chemical what bonding, right? I want to give you a breakdown of what chemical what bonding. So when it comes to what chemical bonding, we have the electrovalent bond, we have the electrovalent, we have the what covalent, we have the what dative, we have the word dative. Now the dative bond is also known as the coordinate covalent word bond. It's also known as the word coordinate covalent word bond. It's also known as the coordinate covalent word bonding. It's also known as the coordinate covalent word bond. Now the coordinate covalent bond, take note, you are seeing covalent here, you are seeing what covalent here. The coordinate covalent bond is a special type of what covalent word bonding, but I will get back to it. So let's start with the electrovalent bond. The electrovalent bond is also known as what the ionic word type of word bonding. Now when we say electrovalent bond, it is a type of chemical bonding that involves the word transfer of what electrons. It involves the transfer of what electrons. Now when it involves the transfer of electrons, it's going to lead us to an aspect where we call the word electropositivity and the word electronegativity. The electropositivity and what the electronegativity. The moment I transfer to you right now, I becomes what electropositive, and you that is collecting, you become what electronegative. Please take note. The element transferring an electron to another element is what electropositive, and you that is collecting is what electronegative. Please take note of that aspect. So that is what is known as what electrovalent what bonding is what a transfer of what electrons. Then the covalent bonding is what sharing of what electrons. So the covalent bonding involves what the sharing of what electrons. Let's say I am not balanced, you are not what balanced, right? So let me just give you an example. The electrovalent bond, common example is found in what sodium what chloride, sodium what chloride, right? So let's move on. Sodium what chloride. So the sharing of what electrons is found in what the covalent what bonding, right? So we have the third one, which is what the dative what covalent what bond. The dative covalent bond is a special type of what covalent bonding that involves the presence of what lone pair electrons. So it involves the presence of what lone pair what electrons. Lone pair what electrons. So when it comes to the lone pair electrons, it means that you are not bringing, I am the only one that is bringing, in order for we to what become what balance. So that is what is known as what the lone pair what electron. But our major focus, which is organic chemistry, is based on what the covalent what bonding, which is what the sharing of what electrons, right? And this sharing of electrons, right, is based on what carbon, right? And when they share electron like this, they turn to form what long chains, right, or ring chains, right? And this will bring us to the unique nature of carbon, which I talked about in the introduction of this video, which is known as what catenation. Have you seen how everything is moving? From there we are moving to the next one, for the next one we go back and still link it up. So that is just how what it is. So let's talk about our bonding in organic what compounds, right? The bonding in organic what compounds. So organic compounds generally forms what covalent what bond. Organic compounds generally forms what covalent what bond. Organic compounds generally forms what covalent what bond. Now note, there are two types of covalent bonds, but I bet you have not heard about it before. There are two types of what covalent what bond. So we say covalent what bond. There are two types of what covalent what bond, and for the two types of covalent bond, we have the word sigma and we have the word pi bond, right? We have the sigma, which is say number 6, right? Number 6, something like this. We have the sigma and we have the pi word bond. So for the pi bond, we have something like this, right? So we have the sigma and we have the word pi word bond. Now take note, in terms of stability, remember I talked about the hydrocarbons, I talked about the alkenes and what the alkynes. So in terms of stability, which is the major purpose of what bonding, right, in order to attain what stability, right? So in terms of stability, alkanes are the most what stable, and alkynes are the what most what unstable. Please, it is very very important that you take note of this word point. It's very very important you take note of this word point. So let's talk about the word sigma word bonding, right? Let's talk about the sigma bond. We are going to talk about the word sigma bond and their word formations, right? We are going to talk about the sigma bond and their formations. So the sigma bond, it says the sigma bond, please take note. Take note of this. So this is chemistry 102 most repeated questions. The sigma bond is the backbone of organic chemistry. I didn't say covalent bond. Oh. I said sigma. I have to break it down. The sigma bond is the backbone of organic chemistry. Note that the sigma bond is an example of a covalent word bond, but the word sigma bond is the word backbone of what organic word chemistry. It is stronger than the word pi word bond, right? It is stronger than the pi bond, and it is formed in 3 ways. So we are going to talk about the formation of the word sigma word bond. Remember, from the beginning of this class, I talked about the s orbital. I said the shape of the s orbital is what? Spherical, right? And I talked about the shape of the p orbital. I say it's what? The dumbbell what? Shape. If you have been going to the gym, you get to see a dumbbell, right? You see the way it is, right? It is just like saying letter number 8, right? Number 8 that has fallen down. So this is our number 8, right? But when 8 has fallen down, it is now like this. So this is what a dumbbell what shape, and that is the shape of the word p word orbital. It is very very important that you take note of what this, right? So let's talk about each of them. Number 1 formation of the s orbital of the sigma bond. Sorry, the formation of the sigma bond is overlap of 2 s orbital. Overlap of two s what orbital. Remember I said the shape of the s orbital is what spherical, right? So we get to see spherical, right, and spherical, right? But we say what overlap. That means it is lapping. Imagine when you enter a bus and you say someone should lap you, the person is sitting on your lap, right? So that is what is known as what overlap. And you get to see that there's an interception here. So this interception, or where they cross each other, that is what is known as what the sigma what bond. That is where the sigma bond is being was formed. Please take note of that because I want to clean it. So I'll move on to the next one. So let's continue. Let's continue, right? Let me clean this one, right? So this the second formation of the sigma bond, that is number 2, is overlap of 2p orbital, right? Overlap of 2p orbital. Of 2p what orbital, right? Overlap of 2p what orbital. So the 2p orbital, remember I said it's what a dumbbell shape. Number 8 that has fallen what down. So what we are going to have is what 8, and we are going to have another what 8 here, right? So this place that they are meeting, right? This place here, or this point here, is what is known as what the sigma what bond. It's where the sigma bond is being what formed. The overlap, right, where they meet each other is where the sigma bond is being what formed. Then moving on to the third formation is where the overlap of what of one s orbital, overlap of one s orbital and one p what orbital. So we are going to get one s orbital and one p what orbital. So what we are going to get is this is our s orbital, and we are going to get what our p what orbital, right? So in these points that they are overlapping, that is where our sigma bond is being what formed. It is as easy as what ABC, right? It's as simple as what ABC. This is 1, 2, 3. These are the 3 formations of the what the sigma bond. Overlap of 2s orbital, overlap of what 2p orbital, and overlap of what 1s orbital and what 1p orbitals, right? So that is just it. And we say the sigma bond is the most strongest. The sigma bond is stronger than the what pi what bond. The sigma bond is in charge of the what alkanes, and that is why we say the alkanes are the most what stable. And don't forget we say the sigma bond is the backbone of what organic what chemistry. So let's move on to the next one, which is what the pi bond. The pi what bond. So in our next class, we'll be talking about what these hydrocarbons in their what places. We're going to talk about the what alkanes, talk about the substitution, I'm already telling you. We're going to talk about the reactions that the alkanes would undergo, the preparation and their preparations, and what lot other what stuff, their characteristics. So we are going to break them down each other, right? So that is what we are going to do. And after that, we move on to the functional group and the what rest, where we start entering the stereochemistry into what into 2. So let's move on to our pi bond. So our pi bond is just formed in one way. Our pi bond is just formed in what one way. This is our pi bond, right? Our pi bond is just formed in what one way. The pi bond, like I said, is found in what alkenes and what alkynes. It's found in what alkenes and alkynes. They are formed by lateral overlap of 2p what orbital. They are formed by lateral overlap of 2p what orbital. So this is the p orbital, right? This is the p orbital. But I say overlap, right? So this is the p orbital. 8 that are solid. But now I say lateral, that means they are going to stand, right? So it's not going to fall again, it's going to stand. But I said lateral what overlap, although they are standing, but we say lateral overlap, that means it's going to what overlap each other, something like this, right? So you get to see here, right? So this is what pi what bond. Anywhere they overlap, that is where the pi bond is being what formed, right? So that is just what it. And that is the concept of what hybridization and bonding when it comes to what organic what chemistry. It is very, very important that you understand this what concept. Talked about hybridization, which is simply the what mixing or the blending of what 2 atomic orbitals. It can be 2, it can even be more than what 2, because we have the word sp², we have the word sp², we have the word sp², and the word rest. But our major concern at first term 102 is concerned, or basic chemistry is concerned, we'll be focusing on what the sp orbital. So this is just it. If you need any further clarification, don't forget to drop in your comments, and also don't forget to do my assignment. While I've talked about the atomic orbitals, I said the principle of the rules, I said that the innermost shell must contain a maximum of 2 electrons, and the one that also says that filling must be done singly before what pairing what occurs. So just take note of this, and in our next class we'll be focusing on the various hydrocarbons, that is the alkanes. We are going to talk about everything in the alkanes. We're going to talk about everything in the alkanes and everything in the alkynes before we move on to a functional group, and before we move on to titrations and the what stereochemistry in what details. So that is just it. Until I see you in my next class, always remember that I love you. Thank you.